question is evaluate the following integrals. As limit of sum question is 0 to 2. 0 to 2 e raised to x dx. 0 to 2. This integration we have to add there. Find also by find value also by actual integration. Evaluate by limit of sum and then find actual integration. Now function is 0 to 2 e raised to x. Question is 0 to 2 e raised to x dx. Now limit of sum method. First take fx is equal to e raised to x. Closed interval take 0 to 2. Closed interval 0 to 2. Divide this interval as divide as first take 0 plus h, small increments 0 plus 2h, h is small increment, next is 0 plus 2h, sorry plus 0 plus RH, 0 plus NH is equal to take upper limit 2. Divide this interval as 0, lower limit, 0 plus H, 0 plus 2H, 0 plus RH. This is rth term, 0 plus NH, that is nth term, is equal to take upper limit 2. That means we have NH is equal to 2. Fx is e raised to x. Now ftr is equal to e raised to tr. Fx is e raised to x. Ftr e raised to tr is equal to e raised to tr is rth term. 0 plus rh, that means rh. Zero plus rh, that means rh. Rth term is tr, rth term is rh, e raised to rh. Tr, rh, e raised to tr, e raised to rh. Now next step is this integration we have to calculate or find by limit of sum. So take limit as n tends to infinity of sum. That means summation sign. Limit of sum, limit of summation sign ftr delta r. Here ftr we get. ftr is e raised to r. Similarly, delta r is take h. ftr is e raised to rh. Delta r is take h. So summation ftr delta r is equal to limit n tends to infinity. This integration as limit n tends to infinity of sum. Summation ftr delta r. Limit summation ftr is e raised to RH. Delta R is H. Next step is equal to limit as n tends to infinity. If we see, then H is constant and summation e raised to R. R take from 1, 2, 3 up to n. So H summation take values R1, 2, 3 in this way. So is write in bracket e raised to R is take 1 into H is H. Summation, that means plus e raised to R is take 2H plus R is 3H in this way. Limit as n tends to infinity, H outside. This summation we have to take, that means sum plus in this way. R values 1, 2. E raised to 1 into H plus e raised to R is 2 into H, 2H plus e raised to R is 3H in this way. If we see, then this is geometric sequence, geometric series. Geometric series. How it is? First term is, we say A e raised to H, and R we have to find common ratio by dividing this term, next term upon previous term. E raised to 2H upon e raised to H. E raised to 2H, this is minus H. E raised to 2H minus H is H. Similarly, R is equal to e raised to 3H, next term upon previous term e raised to 2H is equal to e raised to 3H. This goes at numerator, minus 2H, e raised to again 3H minus 2H is H. That means this is geometry series with first term e raised to H and R e raised to H. First term e raised to H, R is e raised to H. H. Now sum of the terms Sn in case of this series is formula A R raised to n minus 1 upon R minus 1. This is sum. Find by using this formula Sn equal to A R raised to n minus 1 upon R minus 1 is equal to A is first term, e raised to H, R is ratio, e raised to H, raised to n minus 1, R minus 1, e raised to H minus 1. A e raised to H, R e raised to H, have index n minus 1, R e raised to H minus 1 is equal to e raised to H in the bracket, e raised to NH, minus 1 upon e raised to H minus 1. E raised to H, e raised to NH is 2. NH is 2. 2 minus 1. E raised to value of sum. So put in the equation sum. Therefore, this integration 0 to 2 e raised to h dx is equal to limit n tends to infinity of sum. We get sum is, before that here is h and there is sum. So sum is e raised to h, e raised to 2 minus 1 upon e raised to h minus 1. Look the first statement of limit and put there the value. First statement of this limit in your notebook and put their values. So this side is 0 to 2 e raised to h dx, limit of sum. Before that h is common and that sum is we take. Calculate this value, put here e raised to h, e raised to 2 minus 1, e raised to h minus 1. Next is this limit we also write as limit as h tends to 0. N tends to infinity, we also write h tends to 0. So write e raised to h, e raised to 2 minus 1. This denominator e raised to h minus 1 and take h to this denominator. Here we write h. This term, this h at the, this is the arrangement, h at the denominator. You know the formula, limit as x tends to 0, a raised to x minus 1 upon x is log a. Limit as x tends to 0, a raised to x minus 1 upon x is log a. Here is limit as h tends to 0. H tends to 0, e raised to h minus 1 upon h, value of which is log e. Value here log a, here value is log e. Value of this is log e, but log e is 1. Log e is 1. Remember all this. Remember all this. Therefore, now equal to all these values we have to put. So don't write limit word in place of h. Put direct value of h is 0. In place of h, value of h is 0. So e raised to 0. E raised to 2 minus 1. And for this limit, value of this is 1. Don't write word now limit. Put h is 0. H is 0. This term. Formula of this is 1. Value is 1. You know that e raised to 0 is 1. So 1 e raised to 2 minus 1 upon 1. Final answer is e raised to 2 minus 1. Final answer e raised to 2 minus 1. So e raised to 2 minus 1. This is final answer. But next is the question we have to find that limit by actual integration. Actual integration, that means 0 to 2 e raised to h dx. By actual integration, we now find this value is equal to e raised to x. Integration is e raised to x. Have limits 0 to 2. E raised to x. Integration is e raised to x. Have limit 0 to 2. Fundamental theorem, e raised to upper limit 2 minus e raised to lower limit 0. According to fundamental theorem of integral calculus, e raised to upper limit 2 minus e raised to lower limit 0. That means e raised to 2, e raised to 0 is 1. So e raised to 2 minus 1 and e raised to 2 minus 1, both the answers are same. E raised to 2 minus 1 and e raised to 2 minus 1. Limit of sum, this is answer. By actual integration, this is answer. Both the answers are same.